All right, now that we reviewed completing the square, and if you missed that video, you really probably need to go back and watch it. Let's go through how we use that technique to work with the equation of a circle. All right, how could we solve this by completing the square? I'm not going to go through all the steps. I'm just going to go through the beginning. It starts with a perfect square. X times x would give us x squared, but it doesn't end with 1. Our c value is not a perfect square. So we could move c to the other side, and we have x squared plus 6x equals 8. Because this is a 1, that's what we want. To find out what our final term of the trinomial would need to be in order for it to be a perfect square trinomial, we're going to take our b, which is 6, cut it in half. Half of 6 is 3, and square that. 3 squared is 9. I'm going to add 9. But I have to keep my equation balanced. I added 9 to the left. I need to be sure that I add it to the right as well. Now this is a perfect square trinomial. What times itself gives us x squared? X times x. What times itself gives us 9? 3 times 3. And if you multiply those two things together, x times 3 is 3x. If you double that, you get 6x. So that's what makes it a perfect square trinomial. And then remember, we would just write this as x plus 3 squared equals 17. And then we could go from there. But I'm not worried about solving it. I'm just worried about this process right here. So look at the equation for a circle. First of all, how would you look at this and go, oh, wait a minute, this is probably a circle? Well, in algebra, we never solved an equation that had both an x squared and a y squared in it. X and y are over here on the same side. They're both being squared. So we're going to use completing the square to make it look like our equations did in the previous section, where we were writing them in what we call standard form. Remember, x minus h squared, y minus k, quantity squared equals the radius squared. This doesn't look like that. So we're going to group up the x's and group up the y's and complete the squares on each of those. We'll do it down below. Okay, so here's why we practiced it. Notice there's only a single x term. So that's just x squared. But with my y's, I'm going to go ahead and group them together. And if I simply had a c value, this would be a perfect square trinomial because it starts with a perfect square trinomial. So we can complete the square here. Because there's a 1 in front of the y squared, all I have to do to come up with this c value is cut this b value in half. Half of negative 10 is negative 5, and then we're going to square that. Negative 5 times negative 5 is a positive 25. So I just made the left side heavier by 25, if you will, to keep that scale balanced. I need to add it on the right side, and now things are balanced. Okay, so we have just a single x squared, and now this is factorable. And hopefully we've done enough practice now that you know I could write the same two binomials. So we're just going to write it once to the second power. What gives us the y squared? A y times a y in the front. What's going to give us a 25? A 5 times a 5. Does it need to be positive 5 times positive 5 or negative 5 times negative 5? You know it needs to be negative in order to get that negative 10 in the middle. And then over here on this side, adding the 119 and the 25, we end up with 144. So now this is in the form that we saw yesterday. We should be able to see what the center and radius are. What's being subtracted from x? Nothing. So the x coordinate of our center is 0. What's being subtracted from y? A 5, and this is the radius squared. So remember, our radius is equal to the square root of that number, so our radius would be 12. Okay? All right, completing the square. All right, number 2, let's complete the square in order to graph this circle. Okay? All right. So notice I have some x terms, I have some y terms. They've written it in descending order. I have my second degree terms, my first degree terms, my constant. We just want to rearrange it. We want our x terms grouped up together. We want our y terms grouped up together. And then we could just write our constant. okay? Just rearranging that. So my next step is going to be to complete the square on each of these so that they're trinomials, perfect square trinomials. And we know that C is going to need to go to the other side. So we'll add 12. All right, both of these have ones in front of them. That's good news. I'm just ready to go here. So we're going to have x squared minus 6x. We're going to take half of this. Half of that minus 6 or negative 6 is negative 3. But if you square negative 3, a negative times a negative, we end up with a positive 9. So let's remember that we added 9, okay? Then here we have y squared plus 4y. We're going to take half of that because this is a 1. I can do it this way. Half of 4 is 2. 2 squared is 4. I'm going to add a 4, okay? On the right-hand side, 0 plus 12, I have the 12, but I have to remember that I added a 9 and a 4, and I need to add those on the right as well. This is a perfect square trinomial. It's going to factor into a single binomial. What's the square root of x squared? X. What's the square root of 9? 3. And it's going to need to be a negative 3 times a negative 3. Don't forget the exponent. Plus, the square root of y squared is y. The square root of 4 is 2. And it can be a positive 2 since that's positive. Okay? And over on the other side, we get 25. All right, now it's in our standard form for a circle. What's being subtracted from x? A 3. What's being subtracted from y? This is actually y minus a negative 2. That's what made it become positive. And then remember, in order to find the radius, we're going to take the square root of that number. This is the radius squared. So the radius is 5. So let's graph this circle. The center is located over 3 down 2. And our radius is 5. So we're going to go out 1, 2, 3, 4, 5 in 1, 2, 3, 4, 5 in the vertical and horizontal directions. And then as best I can, I'll sketch my circle. All right, number 2, same process. So we need to group up our x's to start with. This time our constant's already been moved over to the other side. We're not going to have to worry about that. I'm just going to rearrange it. I'm going to go ahead and put them in parentheses. So I have the x squared and the minus 8x. I'll save some room. Plus the y squared and the minus 12y, and we'll save some room. And that equals our negative 36. Okay, making each of these become perfect square trinomials, they both have 1s for the a values. So we can just cut b in half. Half of negative 8 is negative 4. And if we square negative 4, we'll end up adding a 16. Okay, so we added 16. Same thing here. This is a 1. So we're just going to cut this in half. Half of negative 12 is negative 6. And square that. Negative 6 times negative 6 is a positive 36. So we added 36. So on the right, I had negative 36. I'm going to also need to add 16 and add 36. I added them to the left. I have to be sure I add them to the right. So those will just zero out. We can see that we just have 16 over there. All right, the perfect square trinomials both have minus symbols. So they're both going to factor into subtraction problems. So it's going to be the square root of that is x, the square root of that is 4, and it will be minus. The square root of that is y, the square root of that is 6, and it will be minus. Okay, so there's the equation of our circle. What's being subtracted from x? A 4. What's being subtracted from y? A 6. And what was squared to give us 16? 4. All right, so this circle has its center at 4, 2, 4, 6, and then we'll go 4 in each direction. 1, 2, 3, 4 to get some good points through which to sketch our circle. All right, the beat the test question, I'm going to change this problem, and the reason I am is the first one you have in your practice problems is like this, and this is significantly more difficult, yet they never give you a question like it. So let's change it, and this is the one we're going to work. So we have a 9x squared plus a 9y squared plus 18x minus 36y plus 41 equals 0. We have yet to see one where we have a coefficient other than 1 in front of these second degree terms, and I want to show you how to deal with that. All right, so the first thing we're going to do is group up our x's. I'll go ahead and put them in the parentheses. We have a 19x squared and 18x, and we know we want it to be a trinomial. We also have a 9y squared, a minus 36y, and we want that to be a trinomial. And let's go ahead and subtract that 41 from both sides. All right, this is supposed to be a 1 so that we can take half of this and square it. This is exactly what we did in algebra as well. You saw it in our review, but what we want to do is make this a 1. So I'm going to factor it out. I'm going to use the distributive property in reverse. So pulling the 9 out, I'm left with an x squared plus 2x. Do the same thing here. These are both divisible by 9. So pulling that 9 out, I'm left with a y squared minus 4y, okay? And that's equal to a negative 41. Now we're gonna go about it the same way. We are just gonna go through the steps in that this is a 1. So to make this a perfect square trinomial, half of that is 1, but 1 times 1 is just 1. So I added 1. But I didn't really add 1, I really added 9 times 1. I just made this bigger by 9, so I need to add 9 to the right as well, okay? Come here, half of this, now that this is a 1, half of this is negative 2, but if you square negative 2, you get a positive 4. But we really added 9 times 4, I added 36, so I need to add 36 to the right to keep it balanced. So now we're going to factor these, okay? So we have 9. This is going to factor into the square root of x squared is x, the square root of 1 is 1, and this is a plus. Plus 9 times the square root of y squared is y, the square root of 4 is 2, and this is a minus. And that's equal to, let's see, that is 47. Let me just add those really quickly. I should be able to do that. Okay, we just end up with 4. All right, guess what? I'm not done. And the reason I'm not done is this is not standard form for a circle. There are not supposed to be numbers in front of these quantities other than a 1. So what I have to do is divide that 9 away, and I got to do it on both sides, okay? So all the 9s cancel out over here, and we just have an x plus 1 squared plus a y minus 2 squared, and that's equal to 4/9. All right, what's being subtracted from x? It was a negative 1. What's being subtracted from y? A 2. And our radius is the square root of 4/9. And the reason that's simple is because 4 and 9 are both perfect squares. Square root of 4 is 2, square root of 9 is 3, 2/3, you know. If you had any trouble with that at all, you should be able to just enter it as a fraction and get your answer, etc. But that's our radius, okay? So it's centered at negative 1, positive 2, and we're only going out 2/3. So not even a whole step away. I made that center gigantic, but it's just a tiny little circle centered around the ordered pair, negative 1.